So if this question come out in the exam, they didn't say by using graphic calculator. So first thing, I will take my GC and I will key in my Y1 as ln 2x minus 1 minus 3. Okay, I will key in as like that. Then my Y2, I always let my Y2 stay as this. So that during the exam, I don't have to waste time to retype this. And I will always let my Y3 be equal to this. That is my preparation for exam. So these two, I will not change. So that is what I. So actually all these things, Mr. not supposed to tell you, you are supposed to plan for yourself. Are you clear? Okay, since you are not, you haven't learned how to do things like that, so I let you know. So next time, a lot of things you can prepare for yourself. Yeah, all of you are 17 years old already, so you should know what are the things is important to you. For you, you have to prepare for yourself. Like that only you can grow. Okay, so after I got that, so to do the first part, I can use my GC, I can use the solver. Okay, if I don't want to do graph, I can use solver. Okay, what I can do is, for part A, so I'm going to teach you how to use GC. So that is the first thing you do. Okay, second, after that you click from there. Then for part A, correct, I can use solver to help me to do. I can also use graph. There are two ways. When I say solver in your calculator, it's called numerical solver. So what you do is you key into your numerical solver. You key into your numerical solver. You have the E1 and E2. Am I right? When they ask you to find the x-intercept, it means fx equal to 0. Correct? Fx is in your y1. Am I right? So you put your E1 as y1 and put your E2 as 0. Try to use numerical solver quick. If you don't know, let me know, please. Okay, then who is that? Hello, Tom, can you please? Okay, that is the meaning of x-intercept. So everyone, you should know what is the meaning of x-intercept. Okay, x-intercept, that means find the value of x when y equal to 0. So there will be a x come out, correct? And you know that the domain here is x must be greater than half, am I right? So you try to put a value that is more than half. Okay, like for example, you put 1. Yeah, then you put alpha 3. Alpha enter, sorry. Alpha enter. So what do you get? 10 point something. So you can straight away write down the answer. The x-intercept.
Miss.
Yes.
Where can I find this numerical solver? I can't find it.
Where can you find numerical solver? I don't know. You just press your calculator and try to find. Okay, you can find numerical solver under math. You didn't attend my previous class, is it? Have I taught you how to use numerical solver? Young man, you didn't attend my class? You were there.
Yeah, I just couldn't remember that one bit.
You cannot afford not to remember. I'm not trying to be sarcastic. I'm telling you the truth, okay? So you got 10 point something, got 10 point what? 10.5. So you see? Okay. Yes, young man, over there, can you find numerical solver? Hello? The one who asked for numerical solver, can you find numerical solver?
Yep, yep.
Yeah, under right below, okay? So
Yes.
now, I want to explain certain thing. There is something happened to the other class. Okay, when I teach them how to use numerical solver that time. Okay. Hello? Can I? Okay. So this is, I will explain why this become like that. Okay. If now you go back to your numerical solver, everything is there. You try to change your value of X to become 6 or 7. Okay, then after that, you press alpha enter. What do you get? Same thing. You all get same thing. Oh, because the other class, some of them get 400 plus. You all didn't get 400 plus. I mean, something wrong with them. There is something wrong with them. So there's no issue on that. Okay. Anyone got that issue? Because I just want to let you know, sometimes the answer from the numerical solver, correct? You cannot trust 100%. So I just want, over this, not everyone got 10 point something again. Okay. Oh, that means there's something happened. Oh, that is the other question, not this question. Okay. The very first question that we do, 2x e to the power of, that is their question. You see, I forgot. I remember the wrong thing. Okay, so now issue. Okay, you see, that is how you use your graphic calculator to help you. Okay, because why I prefer you to go for numerical solver instead of graph, because sometimes you very difficult to get the graph. Another way to get this answer is also you graph out, correct? So this is one of the method. Another method will be you draw the graph, then you find the x-intercept. Hello? Still remember from the graph how you get the x-intercept? Okay, so that one I leave it to you. Okay, we are done with part A. Okay, so now I want to get into part B. Okay, part B, I can also use my graphic calculator. Okay, how I use my graphic calculator for part B? Can someone advise? How are you going to use your graphic calculator from part B? You call out your Y1, you put 0. Right? Then what do you get? You enter, you get, what is the calculator tell you? Math error. Okay, whenever the calculator come out with math error, that means there's no answer. Okay, if there's no answer, so the question asks, can F0 be found? So the answer, no, can't. Correct? Okay, can't be found. So what do you mean by when I ask you to look for F0? When x equal to 0, whatever y that you obtain is called y-intercept, correct? It's called a y-intercept, am I right? Am I right? So you can't find F0. What is the reason? Because x equal to 0 is not part of the domain. I give reason for myself. Exam, you don't have to. So what is the significance of this result? This is the significant part of it. What is the significance of this result? There is no y-intercept for this function. That is the significance. You have to know the meaning. When they ask for significance, that means they ask for the meaning of f0. So you interpret. If you can't find f0, means the significance is there isn't a y-intercept. That means you interpret to the examiner the meaning of f0. Got it? Yeah, if you can't find x-intercept, that means fx equal to 0, there is no solution. That means there is the significance of it, there isn't an x-intercept. Or you can say the graph of this function never cut the y-axis. Can I not? So that is a significant part. Okay, part C. Find the domain. Whenever you see a ln function, whatever in the ln must be greater than 0. So x must be greater than half. So therefore, the domain. So in the exam, you can straight away write down the domain. All this working is not necessary. Hello? Are you clear? I write it down because I want to show to how I get the domain. So every time when you see my answer in the marking scheme, correct? I purposely do it in such a way that so that my student read through my marking scheme, they understand what am I trying to do. There are certain steps in the exam, it's not necessary for you to write down. Are you clear? Don't take my marking scheme as every step that is necessary. It's just a model answer. It may not be the best answer. Are you clear? May not be the best presentation. Because if you are good with your calculation, correct? You can calculate mentally, correct? So you save a lot of time on writing so that you can check your work. It doesn't mean that the more you write, the higher mark you are going to get. That is not true at this level. Are you clear? Important step. So I will write down x. X is a member or real number, and x must be greater than half. You just write down this one, I give you perfect mark. Okay, now find the gradient of the tangent to the curve at x equal to 1. Okay. Do you know you also can get the domain without doing the working? You just graph it. You just go to Zoom standard. You see that the graph is only at one side, and you can roughly judge what is the value of x. Okay, because it's here. You will see the graph go like that. And if you make your scale 1 unit, correct? You will see that it's over here. And here is this asymptote is about halfway between 0 and 1. Okay, so actually my graph is not accurate. You can roughly get the answer. Okay, so I want to talk about part D. Okay, you can get the answer from part D without doing differentiation. How do you get it? You call out alpha trace y2. You do alpha trace. This is your f prime x. Am I right? y2. So you select Y2, then you key in 1. Okay, what is the answer come out from your graphic calculator? Yes? 2.2. Is it 2? Okay, 2.0. So you just say, okay, F prime 1 equal to 2. You just write down this answer. You get full mark. Okay. Now, for part E, listen, for part E, you can't use graphic calculator anymore. Why? Because the questions ask you to find F double prime X. So part E, so every time when I give you a question, definitely one part, I will test you on how to differentiate. Okay, you cannot run away from that. Okay, so I will need to differentiate twice, double. Second degree differentiation. So I look for my F prime X first. Still remember for ln, get ready the fraction. 2x minus 1 and 2 on top. Dixon, why you switch on your laptop, may I know? Huh? Okay, you are using the laptop. Okay. Okay, so that is your F prime X, correct? So in order to get the second derivative, because up there is a number, so I bring the whole thing down there up. And I will use the chain rule to get the F double prime. Do you know this question? I only give you 2 marks. You get your F prime X correct and F double prime X correct, you get 2 marks to me. Yep. So this will be multiplied by the power take away 1. Time by the derivative of inside. So if you don't write this step, you straight away write this, I will give you full mark as well. Because there are people who can do this straight away. So when I mark like that. 1 mark, 1 mark. Are you clear? So when we come to working, so depend on your ability. If I'm not able to do it so fast, it's better to be slow than to get it wrong. Am I right? So it depends on individual. Okay, so I got F double prime X. Okay, now, but the explain part, hence explain why Fx is concave down for all X in the domain of Fx. Okay, so in this case, the way you explain is very important. You cannot say the graph says so. You cannot say the sign diagram says so. Cannot. You have to explain algebraically. How to explain algebraically? So you look at this function of F prime X. We start with the domain first. That is, X is greater than half. So therefore, my 2x minus 1 to the power of 2. Any square number, can it be negative? No. So you tell examiner this is greater than 0. So therefore, my F double prime X, which is negative 4 divided by 2x minus 1 squared. So in my mind, I should imagine as negative 4 divided by a positive number. What will I get? Negative. So can I conclude that this is always less than 0? So in this case, shown. Because if F double prime X is always less than 0, negative, it means that fx is concave down for all value of x in the domain. So that is how you explain. You cannot draw sign diagram to explain. Are you clear? In this case, you have to look through the function, argue out. Can I? If you just give me the sign diagram, you get 0 straight away under the explanation. Okay, any question? Huh? Yeah. Where got maximum? Where got stationary point? Lesser than 0, ma? I didn't say equal to 0. And f double prime. Concave upward, do you think there is a, okay, if I want to know whether there is a maximum point or not, whether there is a local maximum or global maximum or not, what should I do? Which function should I look for? Should I look for f double prime of f prime? Okay, since you are asking the question, I set extra question for you from here. Show that there isn't any stationary point for y equal to fx. So how am I going to do this? So I have to, when you talk about stationary point, you have to look at your f prime x, correct? So if I ask you to show that there isn't any stationary points for y equal to fx. So every time when you have this type of question, when you want to show, correct, you assume there is. So that is how you do. You assume there is. So if I assume there is a stationary point, so what should I do? Yeah, I put f prime x equal to 0. You make an assumption. So now I put my f prime x equal to 0. Okay, my f prime x is 2 over 2x minus 1 equal to 0. 2 equal to 0. Impossible. You assume there is and you can't find a solution. So that is how you show. Every time when there is a question, so is there a stationary point? No. If there is no stationary point for this case, that means there is no optimum value. That means the graph, if you look at the graph for part F, the graph will go like that. This is your asymptote, x equal to half, and the graph go like that. It will just keep going up, but it increasing with decreasing rate. So in this case, I can describe my y equal to fx function as increasing with decreasing rate. Will it stop decreasing? Will it stop increasing? No. Do you get me? So there is no highest possible value, or there's no local maximum. So that means this function is, we call it a mono. Mono means it changes in one direction only. This is concave down. Concave down got two parts. Concave down, okay, look. So that's why when you say concave down, when I say concave down, look, I always imagine it got two parts. It can be like that, or it can be like that, or it can be like this. That's called concave down. Concave up, it can be like this, or it can be like this, or it can be both. Halfway, halfway. So when you say concave up, there are three possible shapes. When you concave down, there are three possible shapes. Or you don't break it like that. You always take it like this and like this. No, that is how I break it. That's why the graph that we sketched previously, it go like that, correct? So this is concave. So after that, this is convex. You see or not? Hello? Any further question? Graph the function, show the feature you have found. So when I say show the feature that you have found, I go back to here. No, not this page. Yeah, I go back to here. Show the feature that you found. There is a vertical asymptote. And the x-intercept. So when I say graph the function, show the feature that you have found, okay, I give you 2 marks. If you didn't write down the vertical asymptote, 1 mark will be deducted. Or if you don't write down the x-intercept shape, you will get 1 mark. And if you give me the graph without the labeling, okay, I will deduct 1 mark, and without the origin. Yes. So this is x equal to half. I write up here, okay, so that you can see. Are you clear? Make sure the shape is correct. You can exaggerate a little bit, it doesn't matter. We are not drawing to scale. Are you clear? Okay. Got it? Yeah. So is there any question that you want to ask from the exercise? Is there any? No. Okay, if not, so what you can do is you have your y1, correct? Make sure your y2 and y3 equation is not highlighted. So you try to do a zoom standard because this is a polynomial. You don't know what is the domain. So you try to make sure only that is highlighted, that equation, y1 equal sign is highlighted. The rest are not. Check. So then you straight away go to zoom. Then you try to do a zoom standard. You see how it go. It will take some time. Okay. If you do a zoom standard, if I do a zoom standard, correct, I got a very funny curve. Because within this small little space, the graphic calculator give me situation like that. It's as if like a U shape like that. Is that true? I don't think so, correct? It cannot be look like a quadratic. So what should you do? So I go to window. You look at the graph. I want to know exactly what happened to this part, correct? So what should I do with my x minimum? I just put -1. Or you want to put -2 also can, up to you. Okay, what is your x maximum you want to put? Because when you do a zoom standard, it's 10. So I don't think that is 10, correct? Maybe 5 is good enough. So I put 5. You have to use your judgment. Then if you look at here, the negative part and the positive part, I can cut away. Am I right? So I cut. Maybe I just put -2 for y minimum. Then y maximum, maybe I put 2 also. Then I go to graph. Let's see what happened. It appear better, am I right? It appear better. Now it become like that. It can show you some turning point, then some place somewhere here, it go like that, then it go up. Am I right? So now you want to have a better picture of it. What do? You go further down. You can judge from there. Your x minimum is only less than, you can put -0.5, correct? So you have to, based on the graph, and make the judgment. Okay, so I go back to my window. I'm not going to change my x. I'm going to change my y minimum to -0.5. And I'm going to change my y maximum to maybe 0.5 also. So after this, I go to my graph. So you see now your GX graph, it gives you a very obvious stationary point. And here is another one, then you go up. Correct? So look. So there are 2 stationary points here. Can you get this one easily? Yes. You can straight away from the graph. Am I right? Can you find the coordinate of the turning point here? Second trace. Tell me what is coordinate A. (1.25). Correct? Is it 1.25? The x is 1.25, comma. And here I think is, okay, this one you can't find. This is also a stationary point. This is also a stationary point. So this stationary point, what you can do is you can get it from solver if you want to. If you don't want to plot your x double prime x graph. Hello? Okay, huh? So I want you to go back to try to manipulate with it. Okay, so I want to tell you how to draw a sign diagram. And if I'm not mistaken, this is 2. So when you put in your solver, correct? You see, when you put in your solver, you put in any value of x. If it come back to 1.25 again, correct? You try to change your value of x until you get another value. Okay, so go and play around with your solver. Okay, so I'm going to explain part B. So C and D, you please do it by yourself. Huh? Okay. So every time when we want to draw a sign diagram of anything, okay, so first of all, I have to know the domain. Yeah, so X is any real value. Second thing, I must find X when G prime X equal to 0. If I want to draw any sign diagram, I must find the x-intercept of that function. So in this case, we know that G prime X equal to 0 when X equal to 1.25 and 2. Okay, so now G prime X. Mark here 1.25 and mark here 2. Okay, if you have a look at the sign diagram or at the graph, you should know the sign of G prime X, correct? Hello? Or if you don't know, you can use your graphic calculator to test it out. How to test? I call out my Y2, I punch in 0. So I will get negative value. Am I right? Because your Y2 is your G prime X. Then here you get positive, here you get positive. Okay, so all the sign you can test using your graphic calculator, even you don't have the graph. Clear? Are you clear? Okay, now. Allow me to do C and D. Yeah? You go back and find the exact value by yourself. Now, for part C, you can use your graphic calculator and you use your solver. You put Y3 equal to 0. You will get two answers also. Yeah. So you get one of the answer. I don't know what is the answer. The first answer. The first answer should be between 1.25 to 2. Okay. I don't know what is the answer you try to get. And another value of X definitely is 2. So I don't know what is this. You go and find by yourself. What? Anyone got the answer? 1.5. Is it 1.5? Okay. I trust your answer, 1.5. Okay. So my part D, the sign diagram for G double prime X will go like that. 1.5 and 2. And you have a look at this graph. It goes concave up, concave down, then concave up. Okay, you go back and imagine. So concave up, concave down, concave up. Okay, so there are two inflection points. Hello, listen first, please. I want to mention something very important to you. There are two inflection points. That is, it happened at X equal to 1.5 and X equal to 2. So over here, there are two types of inflection point. Okay, so I'm going to draw the G prime X sign diagram and G double prime X sign diagram together for you to see. Do you realize that x equal to 2 appear in G prime X and also G double prime X? So this inflection point, we give it a special name. Here is called horizontal. Horizontal inflection point. The shape changes, but the gradient is 0. Are you clear? Okay. This point is called non. If you don't want to use horizontal, you can use stationary. Non-stationary inflection point. So if I ask for characteristic, describe the nature of the inflection point, you must be able to tell me the difference of these two. You don't just tell me inflection point. You have to tell me whether it is a non-horizontal or horizontal. So a non-stationary inflection point will be a point whereby it's either increasing, Gx increasing with the fastest rate, or Gx decreasing with the fastest rate. In this case, okay, when you talk about polynomial, is in that location, it is increasing at the fastest rate, not other place, because the graph go like that. Do you get me? Because the graph go like this. From here, so this under this location, it increasing at the fastest rate. Because after that, it go up here can be a fastest rate. So that's why I specify here. You see or not? So when you talk about curve property, I tell you it's more difficult than you study your specialist maths. Maths study is much more difficult than specialist maths. The reason is because maths study is a subject whereby you really have to understand it and go about with it. Specialist maths is just you follow the formula and go. You see or not? So please go through the practice. So tomorrow I will use that 1 hour to answer any questions in the until exercise 3D. Then during lecture, I will teach kinematic, and you please download the 2 questions of kinematic that I have posted in Times. You see, there are 2 questions, kinematic. Please post. I am going to use that 2 questions in 1 hour to teach you kinematic, whereby you learn in your high school, your teacher takes so long to teach you. Because I cannot go through everything. Do you get me? So next week, I will teach rate of change and optimization. Then you go for your break. Your break, come back. I will give you 1 week revision. Then the second week after your break will be our SAT 2. No, I'm telling you, I'm planning everything in place for you so that you can have 1 week holiday to catch up with all your work. If you are not satisfied, then I cannot do anything. Are you clear, young people? Okay, please. You have to be very hardworking. Always tip top. Okay, thank you, class.
Thank you, Miss.
Mm,
Yes.
Thank you, Miss.
thank you. I'm going to run to the other class already. I got 3 hours at one go today.